Hi everyone, in this video we will try to solve this problem. Sin x equals to pi and we should find x. We know that this problem has no solution in the set of real numbers, but in the complex numbers we can find x. Firstly, I want to say that we know from complex numbers that e power ix equals to cosine x plus I sin x. For this formula, e power minus ix equals to cosine minus x plus I sine minus x. And we know that cosine function is even and sine function is odd. That's why cosine minus x equals to cosine x and sine minus x equals to minus sine x. And let's put here, this is equal to cosine x minus I sine x. And if we subtract side by side these two equations, e power ix minus e power minus ix equals to this minus this. Cosine x are same, that's why we may cancel it, and I sine x plus I sine x equals to 2I sine x. And if you find sin x from here, sin x equals to e power ix minus e power minus ix over 2I. This is our formula for the sin x and we use from this formula. In our problem, sin x equals to pi, that's why we should write that e power ix minus e power minus ix over 2I equals to pi. Then e power ix minus, we multiply each side of our equation with 2I. E power ix minus e power minus ix equals to 2ip. Then if we multiply both sides of our equation with e power ix, e power ix times e power ix equals to e power 2ix minus 1 remain here, and let's move this to the other side of our equation. 2I pi times e power ix equals to 0. Then if we think that e power ix equals to y, then e power 2ix equals to e power ix power 2, and it does y power 2. And here y power 2 minus 2I pi times y minus 1 equals to 0. This is just quadratic equation, and we should find y from here. We know that the formula for the quadratic equations root y1 and 2 equals to minus b and 2I pi plus minus the square root of minus 2I pi squared minus 4 times a and c. 1 times minus 1 over 2a. 2I times pi plus minus the square root of, this is equal to 4 minus 4 p squared plus 4 but over 2. Then this is equal to I times pi plus minus, this is equal to the square root of minus 4 times pi squared plus 4 equals to the square root of minus 4 times pi squared minus 1, and it does I times 2 times the square root of pi squared minus 1, I times pi plus minus 2 times I times the square root of pi squared minus 1 over 2, and 2 and here 2 are same, that's why we may cancel it, and it does I times pi plus minus I times the square root of pi squared minus 1. This is our y. y equals to I times pi plus minus the square root of pi squared minus 1 times I, and it does I times pi plus minus square root of pi squared minus 1, and y equals to e power ix. E power ix equals to y, and e power ix equals to I times pi plus minus the square root of pi squared minus 1. If we apply ln to the both side, ln e power ix equals to ln I times pi plus minus square root of pi plus minus square root of pi squared minus 1. ix equals to ln I times pi plus minus square root of pi squared minus 1. And if we find x from here, x equals to ln I times pi plus minus square root of pi squared minus 1 over I, and multiple both sides of our fraction with I, and this is equal to minus I times, this is equal to minus 1 minus I times ln I times pi plus minus the square root of pi squared minus 1. Then we know that ln a times b equals to ln a plus ln b. This is formula, and here we can see multiple. This is equal to minus I times ln I plus ln pi plus minus the square root of pi squared minus 1. This is just number, and we should find ln I. If we think that ln I equals to y, and e power y equals to I, and e power ix we know from complex numbers that equals to cosine x plus I sin x, you can see that the first equation's right side has no real part. That's why cosine x should equal to 0 and I sin x equal to I. Sin x from here equals to 1 and x equals to pi over 2 plus 2 pi n, and n belongs to integers. And if we compare these two equations, y equals to ix, and if we find y, because we should find y ln I, y equals to pi over 2 plus 2 pi n times I, and n belongs to integers. This is our ln I. And let's put this above. This is equals to minus I times pi over 2 plus 2 pi n times I plus ln pi plus minus the square root of pi squared minus 1, and this is equal to, we know that I times I equal to minus 1 and minus here pi over 2 plus 2 pi n just remain here, and plus minus I times ln pi plus minus the square root of pi squared minus 1. This is our answer. And n belongs to integers, we should know. And if n equals to 0, in this case, our answer equals to pi over 2 plus minus I times ln pi plus minus square root of pi squared minus 1. This is our answer. Thanks for watching. Don't forget to subscribe my channel and thumbs up my video.